I'm just going to read through and highlight everything that's not marked on the diagram. A plank AB of mass 20 kilograms. I don't know if it's uniform. And length 8 meters, is resting in a horizontal position on two supports at C and D, where AC is 1.5, dB is 2. A package of mass 8 kilograms is placed on the plank at C as shown in figure 2. The plank remains horizontal and is in equilibrium. The plank is modelled as a uniform rod and the package is modelled as a particle. So now I can mark on the things that I've found in the question. As the rod is uniform, its mass of 20 kilograms acts right at the centre. So I'm going to mark that on to begin with. So that's 20 G, and the distance here I'll mark on as 4. The particle has a mass of 8 kilograms, so I'll mark that here, 8G, and I can mark on the reaction forces at C and reaction at D. I've used that. I'll be using the fact that it's equilibrium in the fact that the clockwise moments balance with the anti-clockwise moments from now on. Find the magnitude of the normal reaction between the plank and the support at C and the plank and the support at D. So for part 1, if I've got to find the reaction at C, I could resolve vertically, but that would leave this reaction in the equation. If I take moments about D, then I will eliminate this R of D because its distance will be 0. I'm just going to write this for the sake of the examiner. So the clockwise force is the distance here multiplied by RC. So 3.5, 8 minus 3.5 is 4.5. 4.5 multiplied by RC, so that's the clockwise moment. And in the anti-clockwise direction I have two forces. I have, this is 2, so this distance is 2 times 20G plus, and the same distance as before, 4.5, 8G. So that means that RC now is equal to all of this, which is 76 G over 4.5, which can be left as, in exact form, 152 over 9G, or 166 newtons. For part 2, I can, if I want to, I can resolve, I can take moments about C, eliminating this force, and to find R at D. But it might be easier just to resolve vertically because it's a simpler equation, so I'm going to do that. So resolving vertically, these two forces added together balance with these two forces here because the plank is in equilibrium. So I have RC plus RD equals 8G plus 20G, so that's 28G, and RC I've already calculated to be 166 newtons, so RD, when I subtract this from both sides, is 28G minus, and I can use the exact form either or there, which gives me 109 newtons, or in exact form of this. For part B, the package has moved along the plank to E. When the package is at E, the magnitude of the normal reaction between the plank and the support at C is R, and the magnitude of the normal reaction between the plank and the support at D is 2R. So it's worth drawing another diagram, or maybe initially just marking these on in pencil. It's easy for me because I can just rub these out. So I'm going to rub out this, and I'm going to rub this out, and now I'm going to move my package along by getting rid of this here so that I can move my package closer to here, because it says here that D is 2R, so this is R and this is 2R now. So this force has increased, it's now double this. Well, if you can see before, the reaction at C was greater, and now the reaction at D is greater. So the package must have moved along closer. So I'm just going to mark the package on here. So I've got the 8G there. It's not too important, but it's nice to have it in perspective if you can. Find the distance AE. So now A to this point E, I can mark that on here as X, because that's what I'm trying to find. So first of all, if I'm as I've got R and 2R and X, so I've got two variables, I'll need two equations. So I'm going to again resolve vertically, because that's the easiest thing to do. So initially resolving vertically, I now have R plus 2R, which is 3R, equals 20G plus 8G, 28G. So that means that R is equal to 28 over 3G, or 91.5. Now I'm going to make a moments equation because I've got to find this distance here. So it makes sense to take moments about A, although it's not the only option. So about A. So I have the two clockwise moments, this distance and this force, this distance and this force, so I'll mark those on. So I've got 4 times 20G plus, and we've got X times 8G, 8GX, equals the two anti-clockwise moments, which are 1.5R plus, and this distance here, which is 6 times 2R, 6 times 2R. It's worth not doing too much working out as you go, because you get marks just for writing out the correct values. So now I'm just going to simplify this a little bit. 8G plus 8GX equals 12, 13.5. And then I'm going to put my R in from here as an exact value, 28 over 3G. And now I'm just need to rearrange and solve. I've noticed that each term in the equation has a G in it, so I'll just divide through by G initially. And so now X is equal to 13.5 times 28 over 3 minus 80 divided by 8. So X is equal to 5.75. Let's just check whether that's realistic. I moved it along to try and make my diagram realistic. This is 4 meters from A, 5.75. I'm comfortable that that looks like a realistic answer, although there's no guarantee it's correct. For part C, state how you've used the fact that the package is modelled as a particle. Just a one marker here, and it's that all of the force, the weight force of the particle of the package acts through one point at E or at C. So the weight acts through one point, and I'll put E because it's at E at the moment. Marks wise, So first of all, there's a method mark for forming moments equation here. It must have all terms must be there, and all the dimensions, so they must each have the force times the distance, even if you've made some mistakes on the numbers. And then there's an accuracy mark for the equation fully correct. Then there's an accuracy mark for 1.66 or 152/9g. You don't get a mark if you leave decimal format multiplied by g on that. For the next part, either an equation for moments or resolving vertically, and that's one method mark for forming the equation, and if it's moments it must have all terms present and all dimensions correct, all terms present for resolving vertically, accuracy mark for all correct, and then an accuracy mark for 109 or in exact form, whatever you might have for that. For part B, I resolved vertically, but you would equally get a method mark for taking moments. Again, same rules apply as before. And then an accuracy mark for either in exact form or a decimal there to 3 significant figures. And then a method mark and an accuracy mark again for the same criteria for taking moments about A or some other place, a method mark for your general solving, and an accuracy mark for 5.75. And then here you get a B mark, an understanding mark, and that's for saying either the weight or you can say the mass acts through one point, either E or C, because it was at C to begin with.